In this video, we want to look at limits of a function. Let's begin, for example, to say if we have something like limits, to find the limits as x approaches to x squared plus 6x plus 8 over x plus 2 or x plus 4. Now, one of the ways to do this is by applying direct substitution. And in this case, direct substitution will work. For example, we can say by solving limit as x approaches to, just substitute 2. We have 2 squared plus 6 times 2 plus 8 over 2 plus 4, which will give us 4 plus 12 plus 8 over 6. So on top we get 20 over 6, which will give us 4. Now, here, direct substitution works. But in most cases, examiners will give you questions that you have an undefined when you use a direct substitution method. What we mean by undefined is when you apply it, you get 0 as a denominator. And when you get 0 as a denominator, it is undefined. So let's see, for example, limit as x tends to negative 4, x squared minus 16 over x plus 4. Here, if we go by direct substitution, we're simply going to have limits as x tends to negative 4. We keep writing this limit until we input that 4, which is 4 squared, negative 4 squared, negative 16 over negative 4 plus 4. So you see on top we have 16 minus 16, which is 0, over negative 4 plus 4, which is 0. So here, this is undefined. So it will now look for another method that we can now use to solve this same problem without having an undefined value. So we can say by factorization, limits as 4 approaches negative 4, we have, let's rewrite the question, x squared minus 16 over x plus 4. So what we'll now do is, what are the two numbers that I can factorize this for? They will be x plus 4 and x minus 4 all over the one down, which is x plus 4. If you check, you will notice that it can cancel this. So we'll say limit as x tends to negative 4, we can say negative 4 minus 4, which will give us minus 8 as the answer. Another example we can look at, let's solve this. Limit as x approaches 5, x squared minus 2x minus 15 all over x minus 5. Here, by direct substitution, we can have limit as x approaches 5. Here is 5 squared, 25. Here is 2 times 5, 10, minus 15 over 5 minus 5. On top, we already have that this side is minus 15. So 25 minus 15 will give you 0. 5 minus 5 will give you 0 likewise. So undefined. So we can now factorize and say limit, let me rewrite the question, as x approaches 5, x squared minus 2x minus 5, 15 over x minus 5. Now, the question here now is, what are the two numbers that when we add them together, we're going to get negative 2. When we multiply them, we're going to get negative 15. The denominator will always give us a clue, which means one of them will have to be negative 5. So, who will I add to negative 5 to give me negative 2? That person is 3. So, I have plus 3 and minus 5. So minus 5 plus 3 will give me minus 2. 3 times negative 5 will give me negative 15. So we will write limit as x approaches 5. We're going to write x plus 3 and x minus 5 over x minus 5. So you can see this takes away this. So we have limit as x approaches 5, x plus 3. So we can now say limit as x approaches 5, 5 plus 3 is 8. So let's look at another question. Limit as x tends to 3, x minus 3 over x squared minus x minus 6. Feel free to pause the video and try it for yourself. By direct substitution, we can have the limit as x approaches 3. We can have 3 minus 3 over 3 squared minus 3 minus 6. So what we're going to have on top is 0 over this is 9 and this side is also minus 9. So we have 9 minus 9, which is 0 over 0, undefined. And we're not wasting our time by showing this direct substitution, because in most cases, most examiners expect you to show the direct substitution first of all before showing them the alternative method that you used. So here we can now use by factorization and say limit as x approaches 3, x minus 3 over x squared minus x minus 6. So what are the two numbers that when we add them together, we're going to get negative 1. And when we multiply them together, we're going to get minus 6. Like I always say, the numerator or the denominator will show you the key. Like here now, the numerator is negative 3. So it means one of the numbers will have to be negative 3. So who will I add to negative 3 to get negative 1? That person is 2. So it means that those factors I'm looking for actually is positive 2 and negative 3. So one of them will have to be negative 3. Now we will now have limits as x tends to 3, x minus 3 over, down we will now have x minus 3, x plus 2. So that this can take away this. We now have limits. You keep writing limits until you put in that 3, which is 1 over x plus 2. So you now have limits as x tends to 3, 1 over 3 plus 2, which is 1 over 5. That is the answer. Now let's look at this particular question. Limit as x approaches infinity, 3x squared, or let's say 3x cubed plus 4x negative 2 minus 12x squared. Okay, since we made this, let's make this 2. Since this is 1, 2 plus 2x plus 4. Now, what we are going to do is, when we are dealing with infinity, one thing you will be sure to do is, shortcut is, you can say limit as x tends to infinity. Just check, the highest power of x at the denominator is x squared. The highest power of x, the degree, is 2 also. So you can simply pick the both that have the highest power of x and divide their coefficients, which is just 3 over 12, which is the same thing as 1 over 4. That is the answer. We can prove it by saying limit as x tends to infinity, which is 3x squared plus 4x minus 2 over 12x squared plus 2x plus 4. What you need to do is divide both sides with the highest power of x, which is what we're going to have is limit as x tends to infinity, 3x squared divided by x squared plus 4x divided by x squared minus 2 divided by x squared all over 12x squared divided by x squared plus 2x divided by x squared plus 4 divided by x squared. Having this now, you can say limit as x tends to infinity. This will cancel out this. So on top there we have 3 plus this will take away this. You have 4 over x minus 2 over x squared. all over, this will take away this, leaving you with 12, plus this will take away one of these, leaving us with 2 over x plus 4 over x squared. So now, when we now substitute the limit, which is infinity, we'll have 3 here plus 4 over infinity minus 2 over infinity squared all over 12 plus 2 over infinity plus 4 over infinity squared. Now, what we'll have is 3 over 12. 4 divided by infinity is 0. Minus 2 divided by infinity square is 0. All over 12. Okay? 3 over 12 there. Sorry. We can put over 12 here. 3 is on top. 2. Let's just separate them. 3 is here. So 2 over infinity is 0. Plus 4 over infinity squared is also 0. So what we have on top is just 3. 3. What we have down is just 12, which is the same thing as 1 over 4, which is the answer. We can also look at another one saying limits as x approaches 0, sine x over x. Here, normally, if we still use the direct substitution, we're going to have limits as x tends to 0, sine 0 over 0. Sine 0 is 0, so 0. Divide by 0, 0. So you see, undefined. Now, another formula we can use now is what we call L'Hopital rule. L'Hopital rule. So, all it simply means is just differentiation. Let's look at the question again using L'Hopital rule. Limit as x tends to 0, sine x over x. We will have differentiate, which is limit as x tends to 0. If we differentiate sine, we will have cos x. If we differentiate x, we will have 1. So limit as x tends to 0, cos 0 over 1. So cos 0 is 1. 1 over 1 is 1. That's the answer.